Hi, I'm Marcus Fayers, founder and editor-in-chief of Dezeen, and welcome to day 10 of Dezeen 15, a digital festival celebrating Dezeen's birthday. I got that a little bit wrong. I'm the founder and editor-in-chief of Dezeen. We asked 15 creatives from around the world to come up with ideas for how to change the world over the next 15 years. Each day, they'll all be presenting their manifestos for a better world. Today, we're speaking to designer and researcher Henna Burney about her proposal. Hi, Henna.
Hi, Marcus.
How are you doing?
I'm fine, and you?
I'm good. So tell us, first of all, where are you? Where are you speaking from?
I'm speaking from the Atelier Lumain. I'm in Arles, in the south of France.
Okay, and what goes on there and what can we see behind you?
So behind me, you can see the research about around textile here. So some examples with the merino's wool and then, yeah.
And Atelier Lumain is part of the vast Lumain arts complex there. But what is Atelier Lumain all about? How many people are there and what do you spend your time working on?
So we are a team of around 20 people working on different projects. So we are designers, architects, and then biologists. So we work here together around different materials and we try to explore them to do innovative projects. Yeah.
And what kind of things have you been working on there? What kind of materials have you been working with?
So I'm being specifically working on salt, of course, and then some research around clay and as well some flowers. So trying to valorize co-products from industries, agricultural industries.
And most of the materials that you work with, in fact, maybe all of them are from the local region, aren't they? So what do? You literally go out on your bike and find some sunflowers or some clay, dig up some clay. How do you find the materials to work with?
Well, actually, it's more like where the issues are in the region, if there's something that we can valorize, because, for example, for the clay, we were trying to source clay in a different way that is not only a quarry that produces clays, but maybe to use waste that is produced from another kind of quarry, for example, a sand quarry. So it's more trying to valorize these materials that are part of the region, but that have kind of an environmental issue. So try to solve this somehow, yes.
And what is the objective of all this research? What do you hope to achieve? And then what do you eventually will do with all these materials?
So first of all is to prove that it is possible to use other kind of materials that are not conventional materials. And then it is possible to reuse and valorize these kind of waste and then to place them in different contexts. I think that's one of the goals, and as well is to mix the different knowledge that are here. So for example, we are all designers, but we want to work with the farmers, we want to work with the salinier, we want to work with other people, and we want to share these, and then yeah, with true materials, let's say, yes.
And presumably there's a sustainability angle to this work. By coincidence, this festival is taking place during the climate conference in Glasgow. I guess a lot of the work is to try and find new, more sustainable materials that we can use in our homes and in our buildings, right?
Yeah, exactly that. It's all around that. For example, what we produce here is maybe we are going to use it locally, and then the same methodology, we can use it somewhere else. Is try to find some solutions locally and then maybe apply the same kind of like a way and path in other places.
Great. So now I think is the right moment for you to share your screen and show us your presentation and your manifesto.
Sure. So,
that's it. Yeah.
Okay. That's good. So, yeah. So as I mentioned to you before, Marcus, I'm working for Atelier Lumain, a research and design platform located in the south of France. So we are a team of 20 people with varied backgrounds, such as designers, biologists, architects, and our goal is to work with the different resources and knowledge of the region and explore them to create innovative and sustainable projects. But today, I would like to talk to you about salt and the research that we have been developing for more than 4 years at Atelier Lumain. and of course, to tell you that it is possible to use salt as a material and to design with it. So we decided to start exploring salt, first of all, because it's an abundant material and because of its historical and social context in the south of France. Salt is part of the local culture, and actually a huge salt industry has been in this region and the city of Salins-de-Gironde for more than 100 years. Around 300,000 tons of salt are harvested every year by the saliniers, which are the only experts in this region of producing salt. This salt is produced and commercialized essentially for the development of chemical products, as well as for frost removal on the roads. But apart from being known as a big industry, the salt marshes are nowadays part of the local landscape, and salt is actually essential for preserving the local biodiversity. So yeah, knowing the economical and environmental role that salt has, our question was how to revitalize the salt production and know-how through design. So we start this research inspired by these salt marshes in the Camargue area. The supersaturated water is the result of the natural evaporation rate, transforming seawater into high concentrated salt solution. This process makes possible the crystallization from the crystal seeds. The crystals attach to a substrate and then they grow layer by layer, forming cubes. This is a natural process that doesn't need any energy besides the natural weather of the Salins. And we are particularly interested in using this natural process as a creative method to produce new applications with salt. But from the collaboration with a product and material designer called Caroline Siebel, graduated from RCA in London, we start to explore the possibilities of using salt as a material, valorizing the know-how from this region. In 2017, Caroline proposed a crystallized glass-like salt material that was chosen to be used as a cladding system for the new Gehry Tower of the Luma Arles Art Foundation. So we start exploring the possibilities of using salt as a material through this application, using as well the crystallization process by placing multiple substrates under the saturated water at the Salins. We observe that through this crystallization process, the crystals grow, embracing the substrate and creating a very rigid material. Depending on the weather condition, this process can take between 5 or 15 days to occur. The development of this cladding system was for us the first example of using the crystallization as a natural additive manufacturing process. Through the crystallization, we were able to produce almost 4,300 crystallized panels and to cover 560 square meters over the 9 floors of the tower. This was possible because of the natural properties of salt. As a natural fireproof material, we were able to use it inside of a public building. So this application that we recently finished and installed is for us a first way to prove that it's actually possible to use salt in new contexts. But as salt has many other properties, our question now is what else salt can do and how to continue using this natural crystallization process. So thanks to the sodium and chloride ion organization, the salt crystals are actually translucent and it makes this material a great light diffuser and reflector. So we decided to explore the interaction between salt and light to reveal this property. And as we learned a lot about crystallization, last summer, one of our projects was to conceive a crystallized lighting using the crystallization in a smart way, which was for us guiding the formation of the salt crystals, making crystallized and smooth surfaces. This is possible through a principle we call the anti-crystallization system that actually we start using it to create very straight edges on the salt panels. So in order to create this object that we could host the multiple electronic components, we work on using the substrate that is in the sample represented by the yarn, where the crystals will grow, and the anti-crystallization system that will stop the crystals, guiding them into flat surfaces. As our goal was to conceive a final product under the water, the blocker or anti-crystallization system, which is in general or a glass or plexiglass material, was for us the perfect way to create spaces into the salt, like roofs or holes to host the LED lights, the hanging hooks, and the spacers. So as we experiment conceiving and prototyping some samples in this way, we realized that the uncrystallized object became very complex to conceive. So somehow a more accurate way to thinking and designing with objects was needed. So the complexity of placing the substrate and the blocker in the right position and predicting where the crystals would grow or not brought us into the development of a digital tool. This was to help to anticipate the formation of the salt material, which happens actually under the water. So yeah, in order to elaborate this tool, we start collaborating with a normal design. It's an algorithmic design studio based in London. So the studio specializes in generating complex geometries for digital and mass manufacturing. And this is one example of what they develop. So we work together with them to develop an algorithm to mimic the NaCl crystals formation on the substrate. So this tool is in one hand a creative device or plugin to design with salt. On the other hand, it will be a monitoring and learning tool to understand how salt crystallization behaves depending on weather conditions. And I would like to introduce you this tool by the following video.
This is Mick from Abnormal Design, and today I would like to share with you our algorithm for simulating the growth of salt crystals. First, let me show you what the default settings look like. As you can see, crystals start forming on the substrate. With the parameters on the right, we can control the growth of the salt. So first, let me increase the growth rate. This will make the crystals expand more quickly. The second parameter controls the chance crystals form secondary crystals on their surface. With this set to a low value, you get a much more homogeneous result, whereas if you increase the split chance, you'll get a way more faceted result. The maximum crystal size limits the size that crystals can get to, and the angle randomness determines how much new crystals are rotated. The minimum split size determines the minimum size a crystal needs to have before it will spawn a new crystal on its surface. There are two types of materials you can use in your mold: substrates, which allow for crystals to grow on their surface, and anti-crystallization material, which blocks growth on their surface. To add in your molds, you just click the plus sign and find the file on your computer. If you have several molds, you can add multiple substrates. To see the final result, including the effect of the anti-crystallization substrate, just click the tick box in front of the Boolean frame.
Yeah. So this digital tool will make possible for designers to start thinking with salt as a material and consider salt crystallization as another kind of manufacturing process to design with. But salt can do more, and we are working as well on the development of two more researches. The first one is salt as an antibacterial and antiviral surface. As salt is an hygroscopic material, it can kill some type of bacteria by sucking water out of them. This is explained by the osmosis process in which water passes out from the cell in the presence of high salt concentrations. Without the water, bacterial proteins cannot function and eventually the cell collapses. By making some bacterial incubation at the atelier, we observed that from 20% of salinity concentration, the bacterial development decreased. And as our perception of hygiene and objects that are touched by many people had changed since the COVID pandemic, this research with salt reacts to this new need of hygiene by exploring the natural self-cleaning properties of salt. So using compressed or crystallized flat salt to produce rigid surfaces, we could place them in high contact areas, for example, as a doorknob, to reduce the spread of bacteria and potentially viruses. This doorknob design system, designed in collaboration with French designer Alexandre Chasseriot, is conceived to host salt cartridges that can be easily replaced when used by the time. Our second research stream is about the properties of salt for energy production using the reverse electrodialysis process. This consists of the salt ion exchange through a membrane, creating a voltage difference using multiple salinity gradients. Through electrodes, this ionic transportation is converted into electrical current to power a device. As the salt marshes are situated at the Rhone Delta, we could imagine using this intersection point for implementing a power plant. And actually, we are literally in contact with the company Redstack, based in the Netherlands, to imagine a future collaboration with them. So actually, we could imagine that the energy produced thanks to the salinity gradient could be used locally. And this implantation could be as well the beginning of an energy transition in the region and the opening for a new economy and innovative applications for salt. So thanks to all of these different salt properties, we believe that salt is a material for the future.
Thank you very much. And just to frame that in the context of the whole Dezeen 15 festival, what you're proposing is that in future we should be looking to materials like salt instead of steel, well, potentially instead of steel, concrete, and those kind of materials. Is that right?
Yeah, well, actually, salt has very particular properties, and I think we should stop thinking that we can replace that materials that already exist. For example, plastic is a great material, and then replace the properties of plastic is difficult. It's more like a place these materials in the right context and in the right solutions. It's the best word to think.
Yeah. And then tell me about the thing you mentioned at the end about the power plant. So I guess the salt marshes act as a giant battery in a way, and it can generate power. How much potential power can it generate?
So of course it depends on the current of the Rhone of the river, actually, because which is going to happen is the mix of these different gradients, salinity gradients, is going to create this water that's going to pass through this membrane. So then I don't know exactly how much power is going to be, because it depends on the current. So this is something that we are actually trying to calculate, but it's going to be, we hope that it's going to be possible to use this power to as an energy source for maybe, for example, for the Salle de Gio, the first little city there, and then yes, to prove that it is possible, yes.
And does that technology exist anywhere else in the world, or is it new technology that you'll be developing?
It's a technology that is in development. So as I said, this is a company called Redstack that is based in the Netherlands, and they have a pilot plant there, and they are trying to find places in the world that can adapt to their requirements. So it's having like a fresh water and salt water in the same time, and then to install like implantations over the world. So it's kind of a new technology, but it's very interesting to be able to collaborate with them and then to do a first application here in this area.
And tell me a little bit about the salt marshes in the Camargue. I mean, they've been there for hundreds of years, right? But you said that it's mostly used for chemicals and for putting on the road. That doesn't sound like the particularly valuable uses of this material.
It's true. So this industry was very famous because they were selling a lot of salt some years ago, and then because this chemical company stops to buying the salt from this company, so they start to reduce the sales, actually. So nowadays there's a lot of salt produced. So every year, as I said, 300,000 tons of salt are produced, and then most of this salt stays in the salt marshes. So as the mountain you saw in the picture. So which is actually for us very interesting, because what we wanted to do is kind of design new applications and kind of think new applications for this salt that stays there. So yeah.
So those big piles of salt in your pictures, they have no use for them at the moment. Is that right?
No, I mean they accumulate because they always sell the harvest they did in the last year. So it's kind of like that, the rotation. So the salt stays there, yeah. So they sometimes, some years they sell more and some years they sell less, but there's always a salt mountain there. Yeah.
And what happens when it rains to those big piles of salt? Doesn't it just all dissolve and wash back into the sea?
No, actually, no, the salt stay there. So there's one part of this pile that is treated with a product that avoid the agglomeration. So because they need to like take the salt with a machine afterwards. So they treat part of the salt, and the other one is not treated. It depends on the use after. So, but the surface of the crystals that are in top of the mountain, of course, they are going to start to, to become a little bit smooth, but actually the salt, they doesn't dissolve. Yeah.
You need a lot of rain, I guess,
Exactly.
to wash it all away. And you say that salts can kill some bacteria, so not all bacteria, then just some types of bacteria.
Yeah, so this is what we are as well trying to develop, so trying to analyze. The little video that I show it was a first sample here we did at the atelier. So by touching some articles in, for example, doorknobs here, so we incubate this bacteria in these petri dishes. We wanted to see which bacteria are there, and then which ones are not going to develop using the salt. But as well, at the moment, we are in contact with the laboratory here in France to analyze the antiviral properties of salt. So we are going to be able to see how salt reacts to the COVID virus, and as well some other two viruses as influenza.
And of course, as you said, salt has been an important commodity for thousands of years. We need salt to live. But have anywhere in the past people explored with using salt as a construction material like you've been doing, or as a way of making products like door handles? Is that the first time that's ever been done?
Well, using the crystallization process, I think is quite new, because as we produce salt here in this region is the sea salt. So the salt is a powder actually, and then we try to agglomerate or use the crystallization process to do something rigid. But of course, there's other parts in the world that the salt comes from the mines. So we can extract big rocks and then use them to do, for example, some construction. As I know in Bolivia, there's some South America, there's some places that have like a hotel with or some construction with salt blocks, but which is particular here is this crystallization process. Yeah.
And what would be your next project then? So you did the interior cladding in the Frank Gehry building. Do you have any more projects lined up to use the crystallized panels?
Well, not for the moment actually. So let's see how as well people react to these materials. So our idea was to analyze how the salt is gonna react, how the salt is gonna age as well. So this is all kind of like a big prototype, let's say. So this is very interesting for us. And then if we are able to use it in another building, of course, will be great. Yeah.
And tell me about some of the other natural materials that were used in that building, because it wasn't just salt, was it?
No, exactly. So we have one other material in the cafe, in one of the coffees on the tower, which is with sunflower marrow. So the marrow is inside of the stem. So we were able to create a panel that is also applied in the wall, that has a very good acoustic properties. So that's one of the materials. And the other one is bioplastic tiles that are colored by some microalgae that we find here in the region as the Dunaliella salina.
And does some of the algae comes from the same salt marshes, right? That's the reason why the water is pink.
Exactly.
And why the flamingos are pink, right?
Yeah, exactly. So this Dunaliella salina microalgae, it's can live in this kind of precipitated water solution. So we are able to extract this microalgae, and then it's a very strong kind of orange pigment that we were able to mix with this bioplastic. Yeah.
And what other projects have you got coming up, either with salt or with any other material? What are you going to tackle next?
Related to salt or other kind of
both salt and beyond salt?
Yeah, so actually now at the Atelier Luma we are developing the new building for us, which is going to be here in the same site in the Parc des Ateliers in Arles, but it's just some meters from the place we are now. And then our idea is to develop, of course, materials that we are going to use inside, as we use the site as a test place, actually, to test our materials. We are going to develop some other acoustic panels with sunflower stem and sunflower marrow. We have a big project as well around the wool, and then some curtains with the felt. We are going to develop some tiles using local clay, as I was mentioned before. So creating a system that is kind of modular. So and we are testing as well, like with a big industry of clay that, of ceramics that is in the south of France. And then apart from that, we are also using microalgae and indigo as a paint for one of the wooden structures that's going to be in this space. So of course we have a lot of how to say objects that we want to produce and develop using our materials, but this is a work in progress.
Well, it sounds amazing, and thank you so much for sharing all your research with us, and good luck with turning salt and all those other things into the materials of the future. Thank you very much, Henna.